Section 12.2 of the textbook is called Keeping a Planet Warm, and this section is the beginning of how we model basically the greenhouse effect of the Earth. And so the first thing that they talk about is that you can have a spherical object like the planet Earth, and I'm using this spherical ball here to play the role of the Earth. And if sunlight, I'm going to use a flashlight for sunlight, shines on the Earth, then that light has a certain intensity, which we use watts per meter squared. That's how much energy every second strikes the surface of the Earth over an area of a meter. And so this incoming light from the sun striking the Earth, if you look down below on the table, you can see that the shadow that's made by the light striking the Earth is a circle. And so to simplify the way we think about this, what we do is we assume that the light is striking a circle and that there's some amount of energy striking that circle every second for every square meter within that circle. And so that circle has an area that is pi r squared, and there's a certain amount of sunlight that's striking that area of pi r squared. Then, as the Earth rotates to create day and night cycles, what we would have is the Earth, the bright side that's facing the sun would be daytime, and the dark side that's on the opposite side of the sun would be nighttime. This daytime side will be warmer, and the nighttime side will be cooler, but we can take an average of the temperature over the entire surface of the Earth. And if we think back to an earlier chapter that talked about radiation, we know that when the surface of the Earth is a particular temperature, then it's going to emit electromagnetic radiation from its surface. That electromagnetic radiation is going to be emitted from the entire surface, so that's going to be the surface of a sphere rather than a surface of a circle. And so in the textbook, they equate, they don't equate, they say that you have some incoming energy from the sun, that strikes a circular area. You can calculate how much total energy per time would strike that circular area. The Earth then rotates, so the entire Earth gets warm, and its entire surface area of the sphere then radiates energy away. And so you have incoming energy from the sun, outgoing energy from what we call the blackbody radiation going away, and eventually the Earth will come into balance so that the incoming and the outgoing create what's called an equilibrium, and the Earth will reach a constant temperature.